Methodology of the Taylor series based computations. Definition of Taylor and Maclaurin series. A Taylor series. A Taylor series is way to approximate the value of a function by taking the sum of derivatives at a given point. Maclaurin series. A Maclaurin series is an expansion of function where the approximate value of function is determined as a sum of derivatives of that function. The Maclaurin series is a special case of Taylor series where the function is expanded by zero. History of Taylor series. The Taylor series was formally introduced by English mathematician Brooks Taylor in 1715. Brooke Taylor was an accomplished musician and painter. He did research in variety of areas, but is most famous for his development of ideas regarding infinite series. He added to mathematics a new branch now called calculus of finite differences. He invented integraton by parts and discovered the celebrated series known as Taylor expansion. History of Maclaurin series. Maclaurin series is an expansion of Taylor series about zero. So we can say that it is a special case of Taylor series. Maclaurin series is named after the Scottish mathematician Colin Maclaurin, who made extensive use of this special case of Taylor series in 18th century. Colin Maclaurin was born in Kilmorden, where his father John Maclaurin was a minister of the parish. Colin Maclaurin also made many contributions to geometry and algebra. Theory of Taylor series. A Taylor series is a series expansion of a function about a point. A one-dimension Taylor series is an expansion of a real function f of x. About a point x equals to a is given by f of x equals to f of a plus f dash of a of x minus a plus f double dash of a by 2 factorial of x minus a whole square plus f cube of a by 3 factorial of x minus a whole cube plus so on, f of n into a by n factorial into x minus a power n plus so on. If a equals to 0, the expansion is known as Maclaurin series. Theory of Maclaurin series. The Maclaurin series is a Taylor series expansion of function about point x equals to 0, i.e. a equals to 0. The formula of Maclaurin series can be written as f of x equals to f of 0 plus f dash of 0 of x plus f double dash of 0 by 2 factorial into x square plus f cube of o 0 by 3 factorial into x cube plus so on f power n into o by n factorial into x power n plus so on. Hence this formula is perfect representation of Maclaurin series. Maclaurin series for some functions function 1 by 1 minus x. Maclaurin series expansion 1 plus x square plus so on. Sigma notation. Sigma n equals to 0 to infinity x power n. Function for cos of x. Maclaurin series expansion is 1 minus 1 by 2 x square plus 1 by 24 x power 4 minus 1 by 720 x cube plus so on. Sigma notation is sigma n from minus n 0 to infinity minus 1 whole power n by 2n factorial into x power 2n. Function e power x Maclaurin series expansion 1 plus x plus 1 by 2 into x square plus 1 by 6 into x cube plus 1 by 24 into x square so on. Sigma notation sigma n equals to 0 to infinity 1 by n factorial into x power n. Integration of 1 plus x minus 1 by 2 into x square plus 1 by 3 into x cube minus 1 by 4 into x power 4 plus so on. Sigma notation sigma n equals to 0 to infinity minus 1 whole power n plus 1 by n into x power n. Function sin x. Maclaurin series expansion x minus 1 by 6 into x cube plus 1 by 120 into x power 5 minus 1 by 50 40 x power 7 plus so on. Sigma notation sigma n 0 to infinity minus 1 whole power n by 2n plus 1 factorial into x to the power of 2n plus 1. Example of Taylor series. Write the Taylor series. A sample problem. Find the Taylor series for f of x equals to sin x about pi by 2. Step 1. Write Taylor series formula. F of a plus x minus a f dash of a plus x minus a whole squared by 2 factorial into f double dash of x plus so on. Step 2. We have the value of a equals to pi by 2. Find the derivatives of function and put the values of a in it. F of x equals to sin x. F of a equals to sin pi by 2 equals to 1. Step 3. Now put the values of derivatives in Taylor series formula, and the required series will is 1 minus x minus pi by 2 whole square by 2 factorial plus x minus pi by 2 whole 4 by 4 factorial minus x minus pi by 2 whole power 6 by 6 factorial plus so on. That's how to find Taylor series. Example of Maclaurin series. A sample problem. Find the Maclaurin series of e into 5x. Step 1. Calculate the first few derivatives for the function until you can see a clear pattern. Usually you will only need to calculate 4 or 5. F of x equals to e power 5x, f dash of x equals to f double dash of x, and then step 2. Fill in the derivatives you calculated in step 1 with 0 as the input. This gives you the value you need to insert in the Maclaurin series. F of x equals to e power 5 into 0 equals to 1. F dash of x equals to 5 into e power 5 into 0 equals to 5. So on. Step 3. Fill in the Maclaurin series with the values you calculated in step 2. E power 5x equals to 1 plus 5 into x minus 0 by 1 factorial plus 5 square into x minus 0 whole square by 2 factorial plus 5 cube into x minus 0 cube by 3 factorial. So on. That's how to find Maclaurin series. Applications of Taylor and Maclaurin series. In first one, in approximate of function value. Second, in measurement of relativity, optics, black body radiation, etc. Third, in calculation of electric dipoles. Fourth, in prediction of velocity of water waves. Fifth, in calculation of construction of buildings, highways, etc. Sixth, also in power flow analysis of electrical power system, Newton-Raphson method. Example, using Taylor series to evaluate limits. Evaluate limit x to 0, integration of cos x by x square. Using the Taylor series formula, the first few terms of Taylor series for limit cos x are